Hey you guys, Lisandro here, and today I'm gonna be doing kind of a I don't know if it's a blog or a tutorial. I guess it's a combination of both. So if you just follow me, hold on, let me kind of get okay, it's whatever, fuck it. Um, so if you follow me to the next slide, I'll show you what this is about. But anyway, I guess I'll get to it. Mainly, what this is about is kind of explaining the concept of um, indestructibility and how to be indestructible. So, if you follow me to the next slide, I'll show you what I mean. Okay, so basically, what I'm referring to is basically the concept of being indestructible. If you're a comic book fan or you've seen in the movies and science fiction mainly, to be more general, in science fiction is very well referenced the concept of being indestructible, and usually what comes to mind Wolverine, the Hulk, and all these other characters, all these references to metals like adamantium, adamantine, titanium, and both a combination of both real and as well as well as fictional metals. Okay, so basically, in real life, things are different. Um, there really isn't indestructibility. It isn't real, or at least in the context of people usually refer to as. Uh, Usually, what people refer to as is basically not being able to be destroyed by absolutely anything whatsoever. Is the concept of it can withstand anything that comes to it, no matter what. Okay, and basically that is impossible because it means that to start off, let me just explain. Here we got a layout of some plate with X number of atoms. Okay, X number of atoms. Okay, they're all tightly bonded together, and it can withstand whatever. Assuming you using uh, a high level of heat or strong mechanical force or whatever you throw at it, even chemicals. It's assuming that that X number of force is applied to this, which means that it's some X number of energy applied, meaning that it's an X number of joules being applied. Okay, usually what destroys something. But because the fact that this can withstand anything is saying that the amount of force or the amount of energy, to be more precise, to in order to break this is infinite. Okay, and the thing is that there is no such thing as infinite energy because energy is finite. Even that means that you would have to spend absolutely a limitless supply of energy. It means that because the fact, and of course, I'm not going to go into the whole concept if energy is finite or infinite in the universe, because that's not going to do it. It means that I would, in the context of all the energy in the earth, I would have to spend all the amount of energy on Earth, and still it wouldn't be enough to destroy this. and such a material does not exist as now. There are, however, very resilient materials. One of the known materials, and is also a very expensive one, is diamond. Okay, if you play Minecraft, what do you call it? You know that that game is about mining diamonds, looking for diamonds. It's focusing around diamonds. But anyway, when we're talking about diamonds, we're talking about a strong structure between carbon atoms. Okay, and because the fact that diamonds have a really strong bond, it doesn't when light goes through it, it does not diffract it because it does not absorb any energy, and it doesn't interact that well with the particles. So therefore, it's not you're not gonna get multispectral light or a rainbow out of the diamond because there's a really strong bond to it. And of course, is very resilient to mechanical force, and I would consider it one of the most resilient in terms of heat because you can literally blow this up. You can literally try to smash it, and you wouldn't really much do that much damage to it as far as the structure goes and all. So the next time you want to test if a diamond is real or not, shine light through it and see how if the light refracts through it or not. If it's rainbow, then that means that that diamond is not real because diamonds have a strong a strong atomic structure. However, when you apply, let's say, an X amount of joules of energy or X amount of heat, okay? When you apply that, let's say you heat up a diamond with a blowtorch, you really heat it up really hot to who who knows how many degrees Fahrenheit. Let's say you heat it up to, let's say, 2000 degrees Fahrenheit. 2000 degrees Fahrenheit. Okay? And what you do is once you heat up that diamond really hot, assuming that you have enough luck heating it up um, because of the strong atomic structure and your difficulty getting it to absorb energy, you basically dump the diamond in a pool of of LOX or liquid oxygen. Okay, liquid oxygen. And if you know liquid oxygen, is like kind of a like a violet blue. It's cryogenic. It's a cryogenic fluid. And if you know cryogenic fluids, they're at sub-zero temperature. They're X amount of negative degrees Fahrenheit. Okay, so what happens is that you dump it in there, and what ends up happening, the diamond ends up getting oxidized. Okay, it ends up getting oxidized, and eventually it dissolves into carbon dioxide or CO2 or carbon monoxide. Either one of those. It all depends on how the balance of either substance that you're reacting with the diamond. Okay, remember carbon comes from the diamond. So depending on how it reacts, you'll get an X amount of carbon carbon dioxide and X amount of carbon monoxide. Now, the reason why that happens is that even though diamond is extremely strong and resilient up to X amount of mechanical force, um, it has its limits because you need an X amount of energy, to break the bonds of the diamond. Okay, so what happens is that you have the energy that let's say 70 degrees 70 degrees Fahrenheit. You have that much energy, and you have the energy that you heated it up to do 2000 degree hold on 2000 degrees F. Okay, 2000 degrees F. So you have this big chunk of energy, which is your delta E. Okay, now of course you also have your X amount of energy uh, from the liquid oxygen, which is X degrees F. Okay, I don't have reference with me right now how much degrees is liquid oxygen condensed at. So, but actually, I do have the time to look. So, let's go ahead and go to Google Chrome. Just give it time. Okay, it's loading up. And yes, I know I have a lot going on my computer because I'm always constantly working on different projects and school and work and all that. Okay, so here we are. Just let it finish loading. Okay, so okay, so liquid oxygen. Okay, okay, and as you can see here, you see it's kind of a violet blue. It's blue here. This guy holding it and all. Okay, so let's check out what liquid oxygen. What temperature liquid oxygen condenses at. Okay, so basically, if you can see here, uh, it condenses at negative 362.82 degrees. Um, oh, actually, that's That's the freezing point. Okay, so let's see grams. Cryogenics is this freezing point. Boils. Okay, boiling point. This is usually the point where they usually condense liquid gases. So it's negative 297 degrees Fahrenheit. Let's say it's negative 298 degrees Fahrenheit. Okay, so let's go ahead and close this. And sure. So what you have here is negative 298 degrees Fahrenheit. So basically, the energy you're dumping into the diamond is no longer this. It isn't this anymore. It's what it is this is this over here. Okay, so this becomes your delta E. Okay, so that's the amount of energy you're dumping into a diamond. Now, now if you look at the formula, delta U equals MST. Okay, this is the formula for to deducing how much energy within mass. So this is your mass. This is your coefficient for the material, which is diamond. Each material has a certain coefficient. It gets a little complicated with certain materials that are polymers, or because they're a blend of different things. Okay, and this right here is your temperature. Okay, in reality, this is supposed to be delta T. Okay, so you have very small mass. Okay, to start off, you have a certain coefficient, and you have like really high temperature difference. So that's gonna be a really large amount of energy you'll be dumping into a diamond, enough to break the bonds and just turn into CO2 and CO gas. By the way, CO gas is highly toxic. Okay, now considering that, you can't uh, you can't in real life be indestructible. The only way you would be indestructible is if you synthesize a material that could absorb an infinite amount of energy, an infinite amount of joules, regardless if it's thermal, chemical, electrical, or mechanical. It will have to absorb an infinite amount of energy without breaking its bonds. And usually, depending on the mass or density of the material, mass is usually high mass materials are usually good at absorbing a lot of energy without breaking their bonds. However, there are some exceptions on some things, like for example, um, electromagnetic bonds. For example, for example, iron is a really hard substance. it can it can pretty much withstand an X amount of joules. However, um, when it comes to mass density, when it comes to mass PV, which is lead, is is weaker than iron, so therefore it's prone to mechanical damage. Okay, how and it not to. However, it does take a lot of energy to heat up lead. Even the disadvantage of it, of course, is that it has a lower melting point than steel, because usually lead is what they use in solder in electronic circuit boards or PCBs, printed circuit boards. So it's malleable and it's easy to work with. So just because a material has a high density does not mean that it's more indestructible. It all depends on a number of different factors. The the strength of the atomic bonds, the density, everything else. So you would need to create something of the sort that could absorb that much energy without it being damaged or destroyed, or at least reduce it to minimal. Now, I'll post in the description a link of this guy that pretty much has a block of titanium, and he shoots a number of different bullets to it, and it hardly does any damage. The only way he starts damaging it is through anti-tank bullets, which it takes a big blow, and even then it has its trouble going through it. It stops the bullet. So anyway, the other concept of indestructibility is being intangible. Okay, in intangible. Okay, intangible, which pretty much means um, hmm, no touch. It pretty much means the aspect that you can't touch it. You can't touch something. And even though that's great and all, and there's number of different things uh, that are much more close into the intangible aspect of indestructibility, you really don't want that type of indestructibility, because you could have, for example, here's an example. Between between me, let's say, let me make a diagram. Let's say here's me, and I know I fucking suck at stick figures. Okay, and usually there's a barrier, and let's say here's some crazy idiot who wants to shoot a gun at me. Let's draw a fucking big ass gun and all, and he shoots he shoots bullets. Okay, it's gonna bullet is gonna hit here, because it's gonna absorb the both the heat energy, which is negligible compared to mechanical energy, and as it's gonna either deflect it and the bullet's gonna ricochet off, or it's gonna absorb it, the mechanical force here. Okay, the thing is that after X amount of bullets that this guy shoots, assuming that he has endless supply of magazines to shoot at, it's gonna eventually start breaking down, and eventually he's gonna break a hole through it, and he's gonna shoot my ass. Okay, now of course that's a problem. It's destructible. It's destructible. It's damaged. However, if you want something in the indestructible, the bullets or anything, you don't have to have anything. You have a big space of air here. And the thing about air is indestructible to bullets. You can't do shit to it or anything. You can shoot the bullets all you like, but you're not damaging the air. You might nick off a couple of air particles or so, but guess what? This bullet is gonna go through here. This bullet is gonna go through, and it's gonna hit me. This thing isn't gonna protect you for shit or anything. It's just gonna stay. It's just gonna stay there, and usually the best type of indestructibility is the type that really doesn't do anything for you. You usually want a tangible indestructibility, not intangible. Now, it does have its practicalities. For example, if you like, let's say, not for protective purposes, but for protecting things. So, for example, let's say that you have um, you have air, and here you have, let's say, you have a memory card. Okay, let's say it's an SD. Freaking crappy looking shit. So, and let's say you're some guy that wants to protect this stuff from, let's say, the FBI, like Apple, like Apple. Let's say you're Apple, and you want to protect it here. Okay, you could protect your data or whatever data you're storing in here. But the thing is that these guys are gonna get to it, and they're gonna try to decrypt it. But let's say that this is the only copy, and you don't want them to get their hands on it, but yet you need it. Okay, so what happens is that they get frustrated, and let's say they say, oh well, fuck it, they scrap this thing. You're fucked because they destroyed the only copy. You needed it, but at the same time, you didn't want these guys to get to it. Now, there is one technology that I was reading an article on, and this technology is that you save. It gives you the ability to save data in air. Okay. Not only do you the pros of it is that you can hide it. Okay, you can hide this, and it best of all, it's intangible, and it is indestructible. I'm having a good day today, despite having my tablet being destroyed yesterday. Uh, I don't know. I'm not having trouble communicating with y'all guys or anything. But anyway, getting back to the point is this: it's indestructible. Assuming these guys are trying to find it, they could be walking right through it and they'll never notice it's there. So you can hide it, and then later on, these guys, when these guys are not looking, they can come over here and they can collect the data and stuff. So, so pretty much, it has its practical applications, but as far as armor and other shit goes, it really sucks. Now the reason I'm doing this little tutorial or blog or whatever fuck it is because kind of express a little bit of my a little bit that I'm upset and stuff, and mainly because I broke my work tablet. Okay, I broke my tablet. Here's my little tablet, and it got broke all fucked up right here. And and what I liked about it was small, it was portable, and I could connect. I could pretty much connect my phone to it. Now here's the little phone, and nah, it's actually like this, like keypad and buttons and all that type of shit right here. And anyway, I broke it because it was small. I could put it in my back pocket, but I was over there. I was by Gulf Gate. Those of you in Houston area, if you don't know where Gulf Gate is, then wow. But anyway, I sat on a bench and I tried to I forgot I had it in my pocket and next thing I know I heard a little sound. Crack. Fuck. Okay. So I was really upset. I was like mad. And the thing is that I got thinking, and it's the thing about my tablet. Here's the ironic thing: my cell phone is my cell phone is all armored with a bunch of shit. I have a protective shock impact case. I have I have a privacy screen, so that's one. Um, I have on top of it three tempered glasses. Then I have another protective screen, and let me see. So that's one, three, four. Okay, five. And then on top of it, I have two layers of transparent tape, which I made it look like a protective screen. So I have like about seven protective layers on it just to make sure that shit doesn't fuck up on me or anything. And I got thinking, and if y'all remember the Nokia's, if y'all remember the Nokia's, okay, you could drop that shit on the floor, and like some meme says, uh, just just a brick phone with all different buttons and shit. You could drop it on the floor and then probably the floor will break or something. I think my floor will break if I drop one of those big block Nokias and all. But here's the thing, I'm fucking mad because they make these phones really sensitive as fuck. You just drop it, you just accidentally drop it and already the screen crack and all. No, wrong one. The screen cracks and everything. And I really hate that because the thing is that because the thing is this. Here's my thought on this. you you barely get out the store, okay? Let's say here's your Apple store, okay? Big as fuck and all, and you're barely walking out, yay, you with your new iPhone and all. And what happens? You accidentally trip on something, and pretty much there goes your phone. It's all fucked up and all. And, and there you spent like who knows how many, what, $299. Now you have to go back in there and pay another 299 just to get the same phone, which you'll probably end up breaking later on and all. And that's what really upsets me and all. Have you seen like a lot of the phones that we used to have, that just a screen and a bunch of buttons and everything? They used to last. You could even break the screen, and they would last and everything. They would still work and all. I had a friend that he burned his phone and it was still working. Although there is one disadvantage that these phones have. If you got them wet, that was it. It was dead. Okay, so getting back to the whole point of indestructibility, there is there is one thing that they have improved on, and I think part of the reason these phones break is because people are careless. People are careless as fuck. Okay, cars don't last because they're either a bunch of people that are either too lazy to check their car, which is there's no fucking excuse not to check your car, or you don't have time. You don't have time, which is perfectly fine and understandable if you have a busy job and all. I don't blame you or anything. And some of these people try to go to go to auto shops, uh, go to auto shops to get it fixed and everything. But guess what? These idiots, there are a bunch of them out there that fucking scam you, because they um you get your, let's say, your little messed up car here, going here and everything. You're going to fix it for something, and then they find a whole number of shits wrong with it, and they end up and pretty much they end up charging you X number of dollars, which is really fucked up in my opinion. But anyway, people are lazy. People don't have time and all, and more people drive carelessly. There's a lot of people that they're drive batshit crazy, like a bat out of hell. And the thing is this: people are careless, and because of that, because the fact people are careless is well, not everyone, for the most part. I'm guilty of this sometimes because I have had multiple phones, multiple MP3 players that have broken, stepped on, and other shit, and it was really fucked up. But anyway, people are careless. And here's the thing: there's an entire market based on this whole deal. There's a lot of industries out there. There's insurance companies on not only your broken electronics but auto insurance and a bunch of other types of insurance. The insurance industry makes a lot of money for your careless mistakes. Okay, but I think I'm diverging from the main point. The main point is that one of the things they have improved on, and I'm glad they have, is that there are, despite the fact there are a bunch of crappy phones that break really easy, um, there are a bunch of phones out there that are very durable, that are top of the line, and they last. You can put water on it. You can put water on it. You can drop it on the floor. You can do all sorts of things, and there are a bunch of electronics that are kid proof, and it'll still work. And there are even some that if you hit it at least one time with something heavy, despite the screen crack, it would still work. And the thing is that that's pretty good and all. Okay, the problem is that you end up with pain. I kind of exaggerate, but yeah, you sometimes you end up paying a lot unless you get into some some contract or something. You know. Anyway, this is supposed to, okay. You end up paying a lot, and that's usually sometimes some of the best things. Sometimes some of the best things should usually cost a lot. It's understandable, but another problem is that you even though you end up paying a lot, there's sometimes you have stuff that they give you crappy shit. They give you crappy stuff, despite the fact that you pay so much money, so much of your hard-earned money for that. I have a friend of mine that um, um that if he's watching this, he'll know I'm talking about him. But there's a friend of mine that he has broken phones and everything, and they shipped him a replacement, and he was really upset because they sent him a crappy one, and because he connected to charge or something like that, and the pins ended up fucking up and all, and but yeah, some of the but yeah, getting to the main point, we can only make things that have a high energy absorption, whether it's mechanical, uh, whether it's mechanical heat energy or something, to be indestructible. And as in the case of the phones and all, or tablets or whatever, they have made quite a few of them resistant and indestructible or close to indestructible. The thing is, my concept of indestructibility is relative to what you're going to be using. Now, if you're gonna have an electronic device that you're gonna only uh, you're only gonna use it you're only gonna use it for lightly. You're not gonna use it heavily or drop shit on it or anything, and can withstand your mistakes of dropping it or even dropping it to the third floor. Uh, yeah, it's virtually indestructible. Actually, it's virtually indestructible. Okay, but but as far as making stuff truly indestructible, and what I mean truly indestructible is it can withstand absolutely anything, an infinite amount of energy. Then that means that means that you made something that can absorb energy, something. Because think about it, if you had something that could absorb an infinite amount of energy, there would be a huge amount of applications for this. There would be a huge amount of applications for this type of technology to make something absolutely indestructible. Think about it. If you had something like this, nothing would be a threat to you. A meteor, let's say, and assuming it was cost effective too. Assuming it was cost effective, and inexpensive and could absorb absolutely infinite energy, you could make almost everything out of this, and you wouldn't have to worry about anything. You wouldn't have to worry about um, people breaking in your house or anything. But I assume it would also produce other problems. Like for example, if you're inside your house, let's say this is let's say this is a house, you're a messed up house, and here's your window, and you're a bunch of flames and stuff. Um, assuming you're or let's say you can't see the flames, but something caught on fire, there would be no assuming you needed to get out, they would not be able to break in there, so your ass will fry in there. Your ass will fry in there, and you're fucked in there. But anyway, I guess just expressing my kind of like me a little bit upset about over what happened, but indestructibility has its place. You really don't want something truly indestructible because um, to start, it's danger as a weapon, is danger to even have it because of the example I just showed. But as well, it does have its advantages and all, because it saves you a lot of trouble on a variety of things. Just like in the phones, where they have made the phones more indestructible and more resistant to water and other stuff. No, but anyway, this and already explained the whole concept behind a tangible type of indestructibility and intangible type of indestructibility. But anyway, that'll be all for now. I hope you learned something. I hope you like this video and all. And please like and subscribe. And I'll catch you guys next time.